are going to solve this problem on minimum number of arrows to burst balloons. So there will be a number of balloons and we have to find out the minimum number of arrows which will be sufficient to burst all the balloons. So what is the problem statement? There are some spherical balloons taped onto a flat wall that represents the xy plane. So this is the xy plane, as you can see the diagram. The balloons are represented as 2D integer array. As you can see in the example, this is the 2D integer array in example 1, where points I, xstart, xend denotes a balloon whose horizontal diameter stretches between xstart and end. So all this arrow rows of this 2D array represents the diameter of the particular balloon, okay, and 10 is the start and 16 is the end. That is, the 10 is the left end of the diameter of the balloon and 16 is the right end. You do not know the exact y coordinates of the balloon, so we don't need to worry about that. Arrows can be shot up directly vertically, so we can shot arrows directly vertically from here in the vertical direction, and we have to find the minimum number of arrows required to burst all the balloons. There is no limit to the number of arrows that can be shot. An arrow keeps traveling up infinitely, bursting any balloons in its path. So each arrow will keep traveling infinitely. Given the array of points, return the minimum number of arrows that must be shot to burst all the balloons. So let's directly jump to the example. This example I have taken in this whiteboard. Now, how to solve this problem? For that, at first, you can see this is a two-dimensional array. Each row represents the diameter extent of that particular balloon. So what if I arrange these rows in ascending order of the second column, that is the rightmost extent of the balloon's diameter, okay? If I arrange the rightmost extent of the balloon's diameter in ascending order, then it will appear something like this, as you can see. Then if I shoot the arrow from here, from the first balloon, the diameter is 6 to 7, as you can see in the x coordinate, it is 6 to 7. I am shooting the arrow from here, and the next balloon's diameter is 3 to 9. 3 to 9, definitely the arrow will go to burst the balloon having diameter 3 to 9 also. Then it will burst the balloon having diameter 6 to 9. Then it will burst the balloon having diameter from 1 to 10 and 4 to 11 respectively. But the moment the balloon with the diameter in the x-axis 9 to 12 comes, this balloon will go in this direction, but it cannot burst this balloon. For this, we have to use a separate arrow. So second arrow comes in action because this first arrow went out vertically up infinitely. So for bursting this balloon with extent 9 to 12, we have to take second arrow, and as you can see the last balloon's extent is 8 to 12, so this arrow will burst these two balloons. So what is the logic? We will take a variable start and we will keep the rightmost extent of the first balloon in this start variable, as you can see 7. So yeah, 7, as you can see at first. 7 is the starting, 7 is stored in the starting variable. 7 is stored in this start variable. Now we will check whether the leftmost extent of the next balloon is less than the start value or not. Whether 3 is less than 7 or not. Yes, then don't increase the count. Don't increase the count variable. Then again, the next balloon's leftmost extent is less than the start or not. 6 is less than 7, definitely yes, then don't increase the count. Then 1 is less than 9, yes, don't increase the count. 4 is less than the start variable, sorry, we are not comparing with the previous row, we are comparing with the start variable. So 1 and 4 is less than start variable, don't increase the count, because this arrow will go up like this and burst all this balloon, because the right extent will definitely keep on increasing. What we have to check is the left extent with the start variable. The start is 7 here. So I hope you can understand this logic. But the moment this balloon comes with 9, 12, here 9, the 12 will definitely be increasing order, 12 will definitely be greater than 7, but this left extent 9 is greater than 7. 7 is the starting variable. For an arrow to burst through all these balloons, this left extent should be at least less than 7, should be at least here, like less than 7 should be at least. But 9 is greater than 7, so this arrow will not burst this balloon. For that we have to increase the count variable by 2. And what else we have to do? Cut 7 in the start variable and we have to put 12, that is this variable. This value we have to put in start variable. The new starting point is 12. We have to check the further balloons with this value. Now 8 is less than 12, 8 less than 12, so definitely this arrow will burst this balloon also. Similarly, if we had more balloons like this same logic will be continued. Now you will understand this with one more example, this one. As you can see, 2 3 2 3, 2 3 2 3 will be like 2 3 2 3, so a single balloon will burst these two balloons, so definitely count will be 1. Now let's jump into the code. At first I will take a count variable to store the count of arrows and initialize it to 0. Then we will sort the arrays using arrays.sort method and put the points array inside it, and we will sort this array on the basis of the second column. So we will sort this array in ascending order on the basis of second column of each row. Okay, so for that a comma b, we are sorting the array in ascending order on the basis of second column of each row. Sorting done. Now we will initialize the start value as this variable here. For this example we will take the start value as 7, that is the rightmost extent of the first balloon. Okay, so points 0 1, and then we will iterate from the second row onwards. Int I equals to 1, I less than points dot length, now what we will do, we will take the current value. What will be the current value of the balloon's extent? We will take the leftmost extent of the balloon. Okay, so leftmost extent will be points I 0. Okay, so the current elements leftmost extent will be the 0th column, that is the first column's value of this particular ith row. We will store this in the current variable, that is curr, and then we will check if cur is less than equals to start. If current value is less than equals to the start value, then definitely arrow will pass through it, right? So we don't need to increase the counter variable, we will just continue. Okay, else what we will do, we will increment the count plus plus, and we will update the start value to this particular right extent of this particular balloon, of this new balloon, for which we need a new arrow. Okay, and at last we will return the count of the minimum number of arrows needed to burst all the balloons. Okay, let's run to see whether any error is there or not. Okay, so answer is wrong. What's the problem? Okay, so we have to initialize the count variable to 1 instead of 0. Sorry, I forgot to mention this point and I did it wrong also. We have to initialize the count variable to 1 because at first we definitely need one arrow. Without one arrow we cannot burst any balloons, right? So we definitely need one arrow. For that we will initialize the count equals to 1. So yeah, the test cases ran successfully. Now let's submit it. And as you can see, the solution is submitted successfully. So yeah, that's it. If you understand this solution, then please do like, share and comment. Thanks for watching my video. Have a nice day.